Okay, hello. So I wanted to share my recent learnings on trying to put LLMs into product. And I've had this intuition that doing like a prompt to Sandbox is like a good concept for learning, but it's like only been an intuition, and through like playing around with it, that intuition has kind of surfaced into concrete things. Because what's very appealing to try to understand with these LLMs is like how good are they at writing code, like generating code. And the good thing about the prompt to Sandbox is that we know the exact output we want, right? It's not completely open-ended code generation. It's a very specific use case. What's also interesting about prompt to Sandbox is that we need to balance determinism versus non-determinism, where the deterministic part is the Sandbox template. Like it needs a very specific structure, but a part of it is non-deterministic. And the only thing that's really non-deterministic is the single file in the Sandbox representing the prompt. That's the only thing that's non-deterministic. And this wasn't obvious to me when I played around with this. So this balancing determinism versus non-determinism is a really good conceptual framework to understand where does LLMs fit in. Because LLMs only fits in where you want something non-deterministic. If you want something deterministic, you should lean towards like programming, traditional programming. Another thing about prompt to Sandbox is that it needs to be super fast. Like if this was going to be a user experience on our dashboard, it would sit right next to clicking a template, which is instant. So it needs to be insanely fast. Another thing is that we have this illusion now that these LLMs just understands how to write different kinds of code. Like it understands React, it understands Tailwind, and understands this and that, but that's just because it's part of its training data. And if you were to create a prompt to Sandbox, it's very likely you want to test a new dependency that was just released. And that's not part of the training data. So how do you teach the LLM how to use that dependency? And that's only NPM dependencies. What about dependencies that's just a script tag you insert into the Sandbox, or a CSS file you insert? What about solutions like SHAD-CN, which is not an NPM dependency and it's not a script tag you insert? How would it be able to learn how to use SHAD-CN, for example? And then another point here is that it has to be one shot. Like there's so much research and stuff going into agentic workflows, but those are slow, right? You have some user input initially to kind of reduce ambiguity of the outcome or the expected outcome. But after that, there's a lot of like validation, or like it writes some code, it validates the code, it writes a test, it validates the test. Like there's just a lot of stuff going on in agentic workflows. But in this case, it needs to be a one-shot thing. And then we also have this illusion when we ask it to write code that, oh, amazing, it's able to write this code. But there's a difference between generating code and generating actual runnable code. So it might seem that it's really good at writing code, but that code needs to be embedded into a larger context. And does it understand that context? So what kind of changed now is, of course, iterating on everything I just talked about. But OpenAI just released a new model as well. So I've been playing around with GPT 3.5 Turbo because it's insanely fast, it's insanely cheap, but it's not like very smart. I wouldn't say smart is a really bad term here, but I'll talk more about it. But then they released GPT-4 Turbo, but it's still like insanely slow. For this use case, it's just too slow, and it's also very expensive, but it is smarter. But then they released GPT-4 Omni, which is probably fast enough. It's definitely cheap enough, and it's even like smarter, or like I don't have personal experience comparing GPT-4 and GPT-4 Omni, but they say that it's even smarter than GPT-4. So that's an important piece of this. And what's also really a good learning from this is that it's not like the slowness and cost of a model isn't like linear, which is a really good thing to pick up from this. So when we build experiences and we see that we can only achieve this experience with a new model, there can be another iteration of that model, which is twice as fast and half the price, right? Because I was very discouraged by GPT-4. Like, I thought it would kind of maybe reduce in cost, but I wouldn't see that it necessarily got faster. So that's a really important learning point here. And then when we say smarter, it doesn't mean that it's better at understanding ambiguity. It's hard to express like what makes it smarter. It does kind of more work. It's almost like GPT 3.5 is afraid to try something, while GPT-4 Omni just leans into it. That's kind of how it feels like. But it doesn't mean that it better understands ambiguity. It's like the only way to better understand ambiguity is to have a shared context. So if you think about two people talking to each other, they do not have a shared context, and one person says something super ambiguous to the other person. Like that other person probably won't understand what the expectation is of the other person. But if they have the same shared context, the same person can say something quite ambiguous, and the other person will actually at least narrow down to a more a closer outcome to what was expected from the other person. And then context is the key word here, right? You still need to provide enough context. It's not enough for the model to be smarter. There still needs to be tools around to build the context for the model to narrow down to the expected outcome. So the way I think about ambiguity, it's really the range of possible outcomes. So if you think about a very generic prompt like create a to-do app, like there is a very large range of possible outcomes there. But the example is quite bad, because when we think about the to-do app, everyone, like us as well, we're kind of, funny enough, there is a huge range of possible outcomes, but everybody is like trained on this very narrow outcome, which the models are also trained on, right? But there are other prompt examples where the range of outcomes is like huge, because it's not trained on very specific outcomes based on the prompt. And that's where it gets like insanely tricky. And you can imagine like a to-do app has been built a million times in code examples in the training data, but we are going to use this for building new stuff, like new products, new ideas that hasn't been done before. And that is where the range of possible outcomes becomes a problem. So the way I think about this now is that the prompt is what you want the sandbox to show. Like you have like a concept. Excuse me. You have a concept. It doesn't describe like the technologies. It's like, what do you want to see? And then you explicitly add what dependencies and resources you want to use as kind of tools to create that concept. And then you click what UI framework, or basically what template you want to use to generate the concept. And the thing is, like, you could state, like, the first iteration was like you only had the prompt, but then you would have to write React in there. React viewer Svelte would have to be in there to choose the correct template. So that's a challenge. You might not write that. But you would also have to write the specific dependencies. And that in and of itself isn't necessarily a problem. The problem is that it needs to learn how to use the dependency. So if you make the dependency part of the prompt, you first get a response for what dependencies that it has detected that it needs to learn. Then you have to go and learn them, and then you have to generate another result. So it just takes way more time to do something. Well, if you add the dependencies explicitly, it can start learning them as the user writes out their concept. Or it could already be cached, and there's no need to do that back and forward at all. Yes, so that's how I think about that now. And this is like the deterministic, non-deterministic part of things. Like you're balancing like what can be, so it's almost like deterministic stuff is like super fast, the non-deterministic stuff is slower. So whatever you can make deterministic, you should try to make deterministic, because it's just computed faster, if that makes sense. So with this iteration, what actually happens when you click like generate React is that if you add a Redux and React Redux as dependencies, if there's no cached results there, it will actually go to npm and it will find the types for those packages. And then it takes those types, it talks to OpenAI, and it prompts it to generate usage examples from this typing. And I did many iterations on this prompting, because what you want is to have a huge ass set of tokens representing types to be a very small set of tokens that really describes how to use the dependency. And initially it was kind of just documenting the TypeScript, right? It was just documenting what it saw inside the file. But this like key usage examples just suddenly resolved it, because then it started describing how to actually use the dependency, and it has like examples. I can show you how it looks like, and that's and that's exactly what it needs. So for example, with Redux, it had like over 6,000 tokens in its TypeScript definition, but that was reduced down to 1,000 tokens with usage examples. And then but if this was already cached, it wouldn't do any of this. It would just be ready to go. So what we do is that we send in the prompt with the usage examples and any resources added, and then we generate the code. And one thing I forgot to talk about in terms of resources, which I guess fits better now that we talked about how to learn NPM dependencies, is that you can't learn resources. So that's a huge ass challenge. An example of that would be Tailwind CSS. Tailwind CSS is just a script tag for a sandbox, and LLMs are trained on a lot of Tailwind. So by just adding the script tag of Tailwind and kind of make that part of the prompt, that okay, we have this script tag and it just happens to have the name Tailwind in it, it actually infers that it should use Tailwind. But it uses Tailwind based on its training data, not because it learned the current API of Tailwind, right? So that is a big ass problem. And then you could say, well, maybe you could just look into the CSS file or the JavaScript file. But what it's like 160,000 tokens in that JavaScript file representing all the different classes and stuff. And then what kind of usage examples would it create? Like the usage examples in and of themselves would also be insanely huge, because there's so many ways to use Tailwind. So this is a really fascinating thing. Like, what if Tailwind was released a week ago? How would you be able to use that in CodeSandbox as like prompt a sandbox? And the point is that this isn't specific to Prompt the Sandbox, right? This is just generating runnable code. So even if you did this locally and you wrote, like you added Tailwind as like a script tag, for example, and then you started prompting something local to start generating code, like how would it understand how to use that dependency, that script dependency? I don't know. But it's very, very interesting. Anyways, and then we generate the sandbox template. So we build up the actual template and we just insert the actual code generated by OpenAI for that single file. And then we create the sandbox and redirect you there. So if we look